is currently a software engineer from the Commercial Software Engineering Division at Microsoft Azure. He works with key strategic customers in Asia to envision and build next-generation cloud solutions on artificial intelligence, big data analytics, blockchain, and IoT, both the Microsoft and OSS stacks. Prior to joining Microsoft, Delon co-founded a number of startups and solution companies in the UK and Hong Kong with broad technology experience. He's also a hardware engineer with experience in sensors, microcontrollers, and wearable devices, etc. So,
cool.
You can start now.
Cool. Let's get started. Thank you. First of all, thank you so much for joining my session today. I think I will be doing two sessions. So the first one is on automated machine learning. So I'm Delon, a software engineer at Microsoft. I work closely with our customers on different AI and machine learning projects. And the tedious parts that we came across are definitely doing data labeling, right? Data pre-processing, or you want to find the right model, you find the best model for your project. Even when you have the best model, you will need to do some sort of hyperparameter tuning, right? So that you can optimize further your model and get a better performance. So that's why I'm very happy to be here today to talk about some of our new updates in terms of our machine learning product spectrum on Azure. So I don't know if you have tried our Azure platform before, but then we used to have a tool or a desktop client called the Machine Learning Workbench, where you can do a little bit of coding and through Jupyter Notebooks, and you can deploy your models and operationalize it through Azure command line, Azure CLI service, so that you can connect the stuff locally to the cloud, and then you can do all sort of training, testing at scale. But this year, we introduced a whole new concept called the Azure Machine Learning Service. And it's available as a Python SDK. It's currently in public review. So after we announced it at our Ignite event, and it's going to be generally available next month. So we introduced something called the Azure Machine Learning Service, where it consists of two parts. So this is the first part, the Python SDK, and the other core part is the Azure Machine Learning Workspace, which I will cover it in a few minutes. So for this SDK, it contains a bunch of powerful Python packages. Most importantly, the stuff that I just mentioned, automated ML, is included in this package, where you can actually test against different models and algorithms automatically. If you are dealing with, say, a classification problem or a regression problem. So you just let us do the job for you and find the best and right model for your project. I will show you a demo later on. And another cool part is we introduced something called the hyperdrive. So as I've mentioned, even if you have the right model or the best model, you still need to tune it, especially when you are dealing with stuff like neural net, deep learning, where the hyperparameter tuning is a very important part of your overall performance. So we introduced something called the hyperdrive, which is also included in this SDK, and you can do hyperparameter tuning by just predefining the constraints, predefining your preferences, and then we'll do the job for you again. So within this SDK, you can also do resource provisioning and model management, especially when you are dealing with tons of different machine learning models and you are containerize them into different images. You are deploying it at different compute targets, for example, Kubernetes cluster, or you can have a computer vision module running right at your edge device, etc. So we have you will have a complete overview and full control of all these applications within our machine learning workspace. Yeah, and also you can manage them through this SDK as well. So the second part is the workspace. So is the ML workspace. Basically, you can work on this workspace through our Azure portal at ease. And we list out all the applications here, what you can do with it. So for example, as I've mentioned, you can choose whatever compute targets, say an HD Insight cluster. If you are dealing with a little bit more static chunk of data, big data, then you probably want to use HD Insight cluster. And later on, I will show you how you can deploy your model in a Kubernetes cluster as well. And of course, if you containerize stuff, you can use our Azure Container Service. And similarly, as I've mentioned, if you are dealing with tons of different models, all kinds of model management work can be done through the workspace itself. And of course, when you are talking about deployments, you can see all your deployments through one single portal, that is the workspace, and you'll see the stuff that you deploy onto your container, or you publish it as a web service, or at your IoT edge device. You will get a very clear view, overview on this. So as I've mentioned, I'm going to cover automated ML. So basically, this is just a slide showing you how it works. So whatever algorithms, for example, if you are dealing with classification, so we will test it against a support vector machine, logistic regression, or tree-based classifier. So as of today, we support regression and classification models only, but of course we are working hard on this to support more different types of algorithms. And what you need to do is to predefine something called the exit score, meaning that which means the accuracy score. So when your model reaches a certain accuracy score, then it will just pause the whole training process and then give you the right model, give you the best model, and you can register it through the SDK. And then later on, you can containerize it. And of course, hyperparameters tuning, you can directly work on it through the SDK to define the number and size of hidden layers. So we will sweep through the number of layers to find the best result for you, and also the learning rate, the batch size, etc. So the only thing you need to do is to define the range of the rate, learning rate, and the number of hidden layers, and the number of parallel jobs. So actually later on, I will also show you, if time is allowed, I will show you a demo on deploying your model in Batch AI cluster. Yeah, so it's a new service provided by Microsoft, where you can manage a cluster of GPU-powered virtual machines to do parallel training in parallel. Yeah, cool. So I think I will move on to show you some demo. Right. One more thing. So all the stuff that I'm going to cover today, it's all available on my GitHub. So I have created so my GitHub ID is TIKYAU. Feel free to follow me. I created a new repository here called PyCon 2018. So I put all my source code, the PowerPoint that I'm using today, as well as the Jupyter notebooks and other materials, all in this repository. So feel free to check it out and follow me on GitHub. So right now, I'm going to show you very quickly how it looks like. So this is my machine learning workspace. So you can actually create this workspace through our Azure portal, and you can just click on the Explore Your Machine Learning Service Workspace here, and to do some step-by-step tutorial. And one cool thing about this service is it's linking directly with our Azure Notebook. Yeah, so of course you can still do everything locally, but then if you use our Azure Notebook, the thing is you can enjoy all the pre-installed packages right at the notebooks, and so you don't need to do a lot of installation work again, and also the Python SDK is also pre-installed within our Azure Notebooks as well. So I have already created an experiment here where I'm gonna work on the MNIST dataset, so the handwritten digits dataset, to do classification stuff. So I'm not gonna run through each of the cell one by one. I will go through it quite quickly, I think, because time is limited. So once you create a workspace, one important thing is to import a config file, import.json, config.json file into your notebook library, so that the notebook itself will link to your specific workspace that you are working on. So as you can see, it recognizes my workspace, the resource group that I created a while ago. And I imported my data set here as well. So here you go. The cool thing about the automated ML module is you can just directly import the library from the SDK and ask the basically this module to work on your data set, to sweep through different types of classification models. So in terms of different iteration like this. So this is a result that I got when I was trying to test it with the AutoML module. And for each iteration, it is testing against like different models. For example, we have the PCA, we have the sparse normalizer, SGD classifier, K-neighbors, etc. And on the rightmost column, you will see the best accuracy score achieved by this particular algorithm. So actually, this is just done by the scikit-learn library, right? So this is just, I'm just dealing with some classical machine learning problems. I'm not touching neural net yet, but in the next demo, I'll be showing you a TensorFlow model, so using a neural net to test my data. And of course, I can output all the important metrics per iteration. So the accuracy score, the precision, the F1 score, the recall score as well. So once the AutoML module identifies the best model, I can do model registration right here. So it's gonna register my model and give it a unique ID. So I can go back to my library here and look for the score.py. Yeah, so actually I missed a step here. So I'm going to create a score.python script here, basically telling them I am now choosing this particular model right here. So let me go back to the score.py script. As you can see, I'm specifying my the path of my model and telling them I want to choose this as my as the best model. And of course, I'm going to write a few more lines of code to check whether my SDK packages are all up to date. So right now, the SDK version is at 1.65, and also you can see my AutoML module, submodule within this SDK. As I'm going to containerize my model, so I'm going to create an environment YAML file to specify all my dependencies, for example, my NumPy, scikit-learn, and of course, most importantly, the Azure SDK, ML SDK. So I'm going ahead to create a Docker image right here. So again, I am specifying the text as classification, and I'm dealing with handwritten digits and my quantifier here, and my model, which is the result obtained from my AutoML module, right? And I can easily, through the Azure ML SDK, again, to deploy my model in a container, in a Docker container, through our Azure Container Instance service. And I also did it through our Azure Kubernetes service to deploy in a Kubernetes cluster. So, and of course, in the end, what I'm doing here is to publish my whole model as a web service, which will be running in those clusters. And let me go back to my workspace. So, yeah. On the left-hand side, it lists out all the applications that you can work on through the workspace. So this is linking directly with my Azure Notebook, as you can see. So you will see the experiment that I created for this demo. So you can see the number of runs, each individual run, and the duration, whether it failed or it's succeeded, the duration, etc. And when I click on compute, so you will see that I have Kubernetes cluster as my compute target, and it gets successfully provisioned, and all the details right here. So, for example, most importantly, the VM size. I'm using a D3 V2 type of VM, and the location is deployed in Southeast Asia. And I can do whatever model management right through the workspace as well. So you will see all the models that I have tested, and so these are all the best model for my project, for my classification project. I can click on to one of them, and you will see the location and also the tags, the version as well. If you have multiple projects with different models, then we will have different versions for it. And in terms of images, so as you can see in my notebook, I'm using the Azure Container Instance as well as Kubernetes cluster, right? So you will see all of my Docker images right here. So I can go and check out one of them. And again, you'll see all the details right here. And the deployments. Yep, and you can see my previous deployment with our Azure Container Instance service. Cool. Let me go back to my Azure Notebook. So towards the end of this notebook, I'm just testing the web service API to see whether it's working. One thing about the deployment is that you will see a scoring URI right here. So you will be using this endpoint when you are calling the web service. Cool. And I'm just testing my API right here, and you will see my results as well. Cool. So I'm gonna quickly jump to my next topic on hyperparameter tuning. So I'm gonna work on the same data set, the same MNIST data set, but this time I'm not using automated ML. So I am going, because I have already got the best model, right? So I'm gonna fine tune it. I'm gonna work on the hyperparameters, and also I will be deploying my model in a Batch AI cluster this time. So as I've mentioned, Batch AI cluster is a cluster of GPU-powered virtual machines, so that you can train different models, different experiments simultaneously to shorten your training time. So again, most importantly, you need to import our Azure ML SDK and also the Workspace here. I'm just connecting the notebook with my Workspace so that they are linking together. And I'm downloading the data set. And right here, I'm creating a Batch AI cluster. So you can do everything through the Azure notebook, or if you have the Azure SDK installed locally on your machine, you can also create a Batch AI through the SDK easily as well. Yeah, so I'm just importing the compute target and the Batch AI compute module here. Most importantly, you have to define your VM size. So do you want it to be auto-scalable, the number of clusters, the minimum and maximum? So if you are dealing with 4 cores, GPU cores, then probably you set it as 4. So you don't want to have more than the number of GPU cores in your virtual machine, right? So next, I'm just running my a Python script to further define my model here, and then creating a TensorFlow estimator. So this project, I'm no longer working on classical machine learning algorithms. I'm dealing with neural network. I'm dealing with using the TensorFlow deep neural net. And I'm creating a TensorFlow estimator here. And again, you can see my results right at the notebook. So apart from automated ML or the hyperdrive capabilities, we have tons of other extensions for your Jupyter notebook, which are all included in the Azure SDK. And I'm just plotting an accuracy graph over my number of epochs. Yeah, there's a slight delay here. So this is the most important part. So as you can see, I'm doing hyperparameter tuning right here. So I'm just importing the hyperdrive module from my Azure SDK. As I've mentioned, you just need to define the batch size, the range of the layers of your neurons, and also the learning rate, and you are good to go. And again, I am doing the same thing as what I've done previously on the model registration and also model deployments. So I have included all the steps right in my GitHub. So you will see the automated ML notebook here, and also the hybrid drive experiment here as well. And my PowerPoint that I'm using today is also being uploaded on my GitHub. I think time is running up, but finally I will spend a little bit time on talking about our Microsoft Learn. So the Microsoft Learn is a free and very quick and role-based hands-on training, which is available for you guys right now. So feel free to check out this link right here. And so we gamify everything, and we also include a code editor, so a browser-based scripting editor right at this platform, so that you can do testing and training, and also trying out different services on Azure for free. And so whenever you unlock a challenge, then you will be earning a badge as well. Yep. So if you guys are more interested in machine learning and deep learning, we have a module called the Create Neural Net with TensorFlow on Azure DSVM, and also how you can interactively work on deep learning projects through the stuff that I just mentioned, the Azure notebooks, on Docker container, or using the PyTorch library, etc. So they are all actually packaged into our DSVM, or deep learning virtual machine, so you don't actually need to do any installation work. And this is the QR code to access to the platform. So I think that's all for my presentation today. During my next session, I will cover a little bit more on the use cases, on machine learning, and the stuff that I did with my customers. So if you are interested in it, feel free to join it. So that's it. Thank you so much.
Thank you so much, Ian. Do we have any questions on the floor? Or perhaps, like, if you're shy, just ask Ian when he's off later.
Anytime.
Yeah. And so now it's lunch break, and we have lunch provided just outside. You can enjoy it for an hour. And please come back about 1:40, because we'll start our next session at 1:40.